everybody. Reporting to you again from the Glamour City, Hollywood.
Our main focus in my organization is mainly on field integrated solar technology, which we are competing not just on solar. It's an active building material. We are the first one in the world to put a thermal underneath the whole system. Both the thermal and electric on the same roof plane have such high efficiency.
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for a show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by Frank Pao, author of For the Beauty of Earth, Solutions to Net Zero Energy. Welcome to the show today.
Thank you. It's my pleasure.
Now, Frank, you're also the chair and co-chair of the Industrial Advisory Board on the Center of Energy Harvesting Materials and Systems.
Yes.
I wonder if you could first tell us a little bit about the center.
The center is mainly for a joint effort with the National Science Foundation. We lay out projects. Then we have to vote different renewable projects for project development with the Columbia University, Virginia Tech, and Penn State. Okay, what we do is we pick out every year when we have the meeting, we pick out certain projects that we will vote on. And we look at how good they are. Once we vote, we will put in money to support it. So each center, like for example, we share the investment with National Science Foundation. Each organization, like for example, my company, SBD Lab, for example, each project is about 40,000. And then the NSF will chip in another 40,000 to get this thing going, just to have some kind of research and development of this project. And then we see how eventually, once the project looks good, we'll go and commercialize it.
Okay, great. Super, thank you. And I believe it's fairly broad, right? I mean, we're talking everything from sensor networks, wireless communication, microelectronics, to even storage, new forms of energy sources and distribution, just to name a few, for instance. Now, specific to your area of expertise, can you talk about what you're doing in the focus areas around energy harvesting for sensors and wireless communication, as well as energy harvesting for transportation?
What we are doing is our main focus in my organization is mainly on the field integrated solar technology, which we are competing not just on solar. It's an active building material, and then we are the first one in the world to put a thermal underneath the whole system, because you won't see it's both the thermal and electric on the same roof plane. So that's why it can have such high efficiency. For example, right now, the regular solar panel is just only 18%. We can get it up in the Northeast, we can get it up to more than double it. And for the places like California, we can triple that, which is almost going up to 60% efficiency. That we can really, is like net zero energy.
So let's why don't we dissect that a little bit, because there are many different approaches to solar, and the conversion and the efficiency of that vary significantly. Yeah. And of course, there's continual papers that's being published on a almost monthly basis, if not even more frequent. Yes. So the layering of the solar plus the thermal energy, and tell me about the source of the thermal energy. Is it ambient? Where exactly is the source of the thermal?
The third thermal is right underneath the solar panel, under the roof tile, solar roof tile. Okay, it's it's right underneath, like what do you call, like a serpentine. I call it thermal tubing, using PEX tubing, right underneath the solar roof tile. But this is really a great combination, because not only it cools off the attic, it also maintains the conversion efficiency, because as the temperature goes up beyond 85 degrees, the solar cells performance efficiency starting to degrade. And if you go up beyond 110, you could hit as much as 10%. And also, it also gives the product more longevity, because as the solar cells, it contracts and expands under the sun. But this way, it will not, because of the thermal underneath that extract, taking out the heat, it will maintain the longevity of the product simultaneously.
It's interesting. Again, not exactly a fair metaphor, but I think about cooling technologies for server, where you're basically taking advantage of the heat. And because, again, there are some rare earth materials, chemicals that's in these solar panels. And of course, to your point, if it gets beyond that 110 °F, starts to really even melt and jeopardize some of these components and ultimately the conversion rate. So here you have a symbiotic relationship where you're harvesting the energy from the heat itself, the sun, but you're also cooling the solar system at the same time.
Yes, yeah,
providing
right.
cooler attic, which is critical for ventilation and overall longevity in the infrastructure.
Right.
Yeah. No, understood. But tell me, where exactly is this from a commercialization? Where has it been implemented?
Okay, it has been implemented actually worldwide, but it's not. One reason there are some holdbacks, because installation is, a lot of contractors don't want to do it because the likelihood of making a mistake is high out in the field. It's a bit cumbersome. But now we are coming up with a better way, so that it's make installation a lot simpler. We make a modular system that you can install all the components in the plant, and then you bring it over to the field and you hoist it up and then put right on the roof. And that makes installation, and you connect either to the inverter or to the battery on the electrical side. And then you connect the thermal with the tank, and you are done. Maybe it makes installation a lot simpler. We are just having a press release on this product. I can send you the press release, so that we hope in the coming months we will start trying to have the commercializing it through installation place in Massachusetts, somewhere in Hyde Park, Massachusetts, Boston, to test out to work it out and demonstrate to people that it can be done quickly, so that eventually, as we produce in the volume part, average household can afford it.
Yeah, just to give the audience a little bit of context, is that while we've seen a pretty wide adoption around solar panels in particular, solar roofs, certainly on a residential, but more on a commercial scale. But certainly on the residential side, one of the things that's been plaguing is the fact that you have CapEx and OpEx, and particularly around the design, permitting, installation, and the maintenance. And that is eating a lot into the overall cost of installation of these residential solar panels. So, having this additional component does add a layer of complexity. And now I get that it's being pre-assembled, prefabricated in a factory setting, but it's a different skill set. When you think about solar install versus more, let's say,
But
Traditional general contractor type of involvement, let's say.
Scott, let me give you an example. We have these installations, as I told you, almost around the world, okay? But maintenance is minimal. That's our experience. Not a single complaint about the performance, and very low maintenance, period.
Yeah. So
Because,
just to be clear, I'm not making a discussion point around the maintenance.
okay.
I think the overall, if you
Yeah.
break down the cost of implementation, it's
Yeah.
expensive because of the project management, permitting, and installation. So
Yeah.
it does add to the at least the initial capex. So the question really becomes is how appetizing is it from a unit economics for
Economic,
companies as well as households to adopt something like this?
okay, that's why I think volume, economy of scale is the way to go. If we have the economy of scale, that's what we are working on, economy of scale, so that it'll be cost effective and make it both installation as well as the product quantity will really, and quality will be prevail.
Okay.
Okay.
All right.
Okay.
Well, again, be very curious to see how this gets adopted, from an industry perspective. But let's transition back to your book, For the Beauty of Earth: Solutions to Net Energy. And one of the things that you mentioned in your book is this notion of elegance, and that
Yes.
think about renewable energy and if energy efficient buildings. How do we take into account the aesthetics and the beauty of things?
Can you repeat that question?
Yeah, so I guess really the
Because,
question is the premise of your book, right? So
yes,
that it's not a
because
pure technology solution, right? So what are the other components besides the technology that we need to factor into account?
okay, the appearance, because that is a lot of today. What I learned when you put standard module on it, it's not only long-term wise, it's not the way to go. It's subject to weather situation, and it's subject to, for example, recently even in Long Island, they have problems with animals trying to use as a shelter inside the panels. Somehow squirrels and all those go into the under the panels and make a nest. Okay, so but once you're totally building is the roof, that's when the elegance is, and it can withstand high winds or low maintenance on taking care of in case there's wind, low pressure or heavy storms. So far, we have no complaint over this past 20 years for the building grade technology. It's almost a zero defect product.
So again, I just want to be clear, for the purpose of this discussion, it's really, we're not talking about the claims of a product, but rather, how some of the advancements being made within the center is really pushing the boundary in terms of, what we're doing around climate action and combating aspects. So maybe why don't we transition to talk a little bit about some of the projects that have come out of the center. I believe it's been associated with the things like, for example, the solar power personal rapid transit.
Solar power.
About that.
Okay, talking about that. Right now, traffic is an issue. And right now we are looking at, mankind has been, the dwelling alone has been two-dimensional for so many years. And traffic is a huge issue these days in major cities, urban area. But now we have a personal rapid transit, which is up in the, it's like Uber up in the air. And it's, you can use your iPhone to book at station or any location, and then it will be right there where you are. And then when you got on the part, you can just go where your destination are. There's no stops. Directly to the destination, and it is use solar power to use it, to apply to it.
Okay, so I'm having a little bit of hard time, and maybe because I didn't have a visual beforehand, but tell us a little bit more about this overhanging automated pod that carries 1 to 2 to 4 people.
Yes, carry one.
What's the mobility system, and because it's a pod, does it then transfer to other types of systems as well?
Yeah, it could be a feeding rail to no. What do you mean transfer to another? Can you repeat that question?
Yeah, so in the case of, let's say, some of the design aspirations from the likes of Hyundai and other companies, they've shown that you could have a pod that could fit into a autonomous flying vehicle, for instance, but it can also fit into a autonomous car on the ground, for instance. So it can have multiple uses, but it's not really fixed. It's a pod that holds a chamber for the people, but the underlying transmission and
for the people, yeah.
Mm-hmm.
Or you can use it for goods transport of materials. Okay, so that's why it's really going. This is how it works. But I don't. For example, the initial personal rapid transit started back in Morgantown, West Virginia, and there was no fatality after all these years since the 70s and it is always on time, because when we a lot of time with current transportation system we have, it's hard to be on. There's no way. It's a lot of time it's hard to be on time, and this will allow that. And West Virginia have proven that students have not. University of West Virginia built it because of West Virginia University. So that's why they managed to have zero. Students have such enjoyed having that system because they're always on time.
Yeah, again, I'm having a hard time following because again, in Korea, I think the brand was I want to say Auto, which is not exactly autonomous, but it's a system that relies on a electrification
Yes.
at the ground level, and it's providing electricity on a conductive basis. So it's continuous, and it has a certain fixed route. In the case of these pods that you're talking about, it's still not clear in terms of the transmission, the engine system, and where exactly the solar aspect is coming.
Solar is from the roof. Solar is from
it's being harvested. So it's being harvested, and
yes.
It's continuous, and it requires no charging whatsoever.
You will have backup support. It will be 24/7 operation. Okay. Now, of course, we have, as I mentioned at the later part of it, we have this we have a consortium organization that will handle this called the Blue Engine, that can generate net zero, no exhaust, no carbon exhaust, to support that. We try to minimize the use of batteries. We hope we can generate, if there's extra spare energy, we will probably use it to generate hydrogen.
Okay.
So that's why any kind of weather situation, it should be reliable.
Well, why don't we move on to briefly talk about Solar Foundry? I guess it works on heterojunction solar cell technologies.
Yes,
Can you tell us about that?
Okay. The Solar Foundry is mainly to automate in a massive way so that we can really make, first, it has less steps on the processing, on making the solar cells, the heterojunction. Currently, the technology is required 13 steps, but Solar Foundry heterojunction is only 6 to 7 steps. That alone increase the throughput. And on top of that, the module manufacturing, it can handle building integrated products because it can vary. The best part is you can have different dimension and thickness of the module, because we lost competition to China because they highly automate, but we can highly automate with different dimension. Okay, so this is the main strength of the solar foundry and volume. So that make this BIPV technology more affordable, which is the way to go.
Okay. Now, let me ask you, we're just starting to see some of these manufacturing capabilities become onshored or reshored, both in Canada, US, and even Mexico to an extent. What's actually being commercialized versus some of these, like, let's call it R&D efforts?
What do you mean? But right now, solar foundry has recently put together, but the design of the machines are ready to go because those are seasoned designers, formerly worked for Meyer Burger. And Meyer Burger has been known for good solar manufacturing systems. They are probably the best in the world because we have been using Meyer Burger system all these years. We don't using better material, reliable material, and don't cut corners. We managed to have zero defect. And now they have high throughput and faster, almost double the speed of what is there in Asian countries.
So again, my question is, I get that it's coming out of the design, but what's the anticipated plan in terms of large-scale production and manufacturing, and ultimately, what's the kind of demand signal that you're seeing?
Well, demand we see, we hope, I think, this is confidential.
Actually, if it's confidential, then we should not be discussing it on this podcast.
Okay. So, but we see, if we use that because another thing is we use this throughput, for the, what do you call, for solar rapid transit. That's a massive deployment of this solar panels and solar energy. For example, it'll be 1 megawatt a mile, and it will justify the high volume production. And once you have high volume production, it comes down the cost. Okay, for BIPV technologies. One reason the BIPV technology hasn't taken off because of cost. But on top of that, we are not calling you a solar. We call active building materials. So that it really, for environmental sake, I think it is better to have it putting on a canopy like the top of the rail rather than on solar farms. You probably know solar farms are not ecological feasible. It would damage the land and for habitat. But when you are up in the air, well positioned, they will be there for a long time.
Okay. Let's kind of bring everything together. So when we think about your book, what can you share maybe one or two additional insights and just kind of put everything together?
What the insights is we need to take action by working together. We can't wait for the climate change to just, let it because I think a lot of people today, my concern is people are not accepting the change of paradigm. Okay. So if we don't act, it's too late for us to make the turn. As I said, climate change wait for no man and without borders. Let's all find ways of working together. That's the whole idea, the main idea of this book. And it could be attractive with BIPV there. It is really attractive. And we have new technology coming up where you don't see the checkerboard. You can choose your color as well. That's what we are working on, working with European companies for that purpose. So it is really trying to make, it's like regular building material, but it's active.
Yeah. No,
Okay.
that is very exciting. It really is something that's been forthcoming for a long time. So we're excited to see that.
Yeah.
So with that, I have been joined by Frank Powell with the Center of Energy Harvesting Material and Systems. Thanks for joining today.
It's my pleasure.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.